Okay, good afternoon, everyone. Today we're going to look at some harder conversion problems. So in the previous video, we looked at some very simple metric system conversions. Now we want to look at what happens when we kick that up a notch. Okay, so start with, let's just write down the question here. So the question is asking here, does Lake Superior has a volume of 2,900 cubic miles of water. They want to know how many liters. How many liters is that? Okay, so this is similar to the conversion that I did in a previous video, but obviously this one is a little more complicated. Here we're starting from a US unit of the miles, and so again that complicates our issue where we'd have to have some US to metric conversions. So in this case we don't have a lot of information, so the 2,900 is where you want to start. Okay, the cubic mile. All right, so like in the previous video, what we can start with are the linear conversions. Okay, so we know that in 1 mile, there is 1.609 kilometers. Okay, so this is a linear value, but we can't just do miles and cubic miles. Those two units don't cancel one another. Okay, so we have to cube this whole conversion factor. Okay, the whole thing has to get cubed because it's just a linear one. So if you take the linear and you go from just simply length and you have to include width and height, and then that makes it, that cubes everything. Okay, so then in 1 kilometer, there is 1,000 meters. Okay, we're doing this because we need to get over to liters, right? And so we generally don't have anything that directly gets us from kilometers or even kilometers cubed to liters. So, but we can get closer by going to meters. So again, same thing happens here where this is a linear conversion that we cube the whole thing. Okay, now we're in cubic meters. Now, generally what we've probably had memorized here is 1 centimeter cubed equals 1 milliliter. Right, so we're kind of trying to drive towards this because this is where at least we probably have something memorized that we can convert from the dimensional term to the volume term. Okay, so in 1 meter, there's 100 centimeters. Okay, again here, this whole term gets cubed. Okay. Now, here this would put us in our centimeters cubed, which is the same as a milliliter. So you could write it as, convert this over, or you would say 1 centimeter cubed is 1 milliliter. Okay. And then our last conversion, which I did leave myself enough room to do. So let me try and scooch this over here. All right, so this becomes rather long. Okay, so we're starting from our miles cubed. We're going miles to kilometers cubed, or miles cubed to kilometers cubed to meters cubed to centimeters cubed is really volume. Again, you could probably skip this step because if we knew that this was essentially milliliters, right? You could then skip this and just go right over here to the milliliter. Okay, so right off the bat, we're now a couple steps in, and it's quite a bit more complicated than one of the ones we've done previously. So here again, you're going to multiply everything on the top, divide by everything in the bottom. But here we can't forget to go back and do our numbers here where we're cubing these terms. Okay, so when you do this, so if you have a scientific calculator, again, parentheses are your friend here. So the 2900 times parentheses 1.609 cubed times 1,000 cubed, again, more parentheses, times 100 cubed, more parentheses, divided by 1,000. And here you're going to get 1.208 times 10 to the 16th liters. Okay, so it's again, these are not particularly similar to ones that I generally ask, but nonetheless, there's these are using the various units, and we have to really kind of think about what is the next step? What do I need? What would I need to get from miles to liters cubed? A lot of times just the simple process of what do I even go next to get here can be kind of hard. Okay, so here we're following just a progression of our things. All right, we want to convert over to the metric system. So the simplest metric system conversion here is kilometers. All right, so I have miles and kilometers. Then kilometers doesn't get me to, I don't know anything about kilometers to liters. So I got to go kilometers down to meters. Now you might go, meters cubed, things like decimeters cubed and things like that. So it depends on what kinds of units you have memorized. But generally, if we just have the straight metric system conversions memorized, we're going all the way down to probably centimeters cubed before we can convert over to liquid units. Okay, so I mean, if you know how many meters cubed there are in a liter, I mean, obviously you could skip quite a few steps in here if you have some of those things memorized. Okay. So let's look at another one here. All right. So this question is asking if the average American, so let's, probably can't read this, but I'll read it out here. The average American throws away 4.5 pounds of trash each day, and the population of the US is estimated to be 311 million people. Calculate the number of metric tons thrown away in the US each year. Okay, so a lot of numbers given in this problem. Okay, so it's quite a bit of information sometimes that we have to process. Okay, and so again, it comes back to where do I start with this? Like, where am I starting with this kind of a problem? Okay, is you want to find the simplest unit. Okay, so let's highlight our units here. What information is pertinent to our thing? All right, so we have 4.5 pounds per day, but that's also per person, right? So it's 4.5 pounds per person per day. Okay, there's 311 million people. Okay, 1 metric ton equals 1,000 kilograms. Okay, 1 year is 365 days. Okay, so if we're looking at these numbers, which one of them would be the easiest or simplest number? Okay, so in this case, hopefully this should highlight that the 311 million is the simplest term. This is just one term, 300 million people. Okay, it is a single term. Here you have three terms. This is a two-term relationship and a two-term relationship. So 311 million people is where we want to start. Okay, now the only term that has people in it, so this is people. Okay, the only other term that has people that would lead us to what is our next step is the top one. So this one has, 4.5 pounds per day per people, essentially per person, right? So people and persons are the same unit here. So okay, so you've got 4.5 pounds per person in day. Okay, so if you have 300 million people, this would tell you how many pounds a day 300 million people would generate. Okay, so the person and people essentially go away. So this leaves you with, in the US population, how many pounds per day do we produce? Okay, but they want to know metric tons per year. So we're in the right unit now, or we're in the right frame of amount per time. We just have to convert over to our next thing. Okay, again, it doesn't matter which unit you take next. I might take there's 365 days in 1 year. Okay, so this would get me into the pounds per year of trash. Okay, but we want to get metric tons. Okay, so there's 2.2 pounds per kilogram, and there's 1,000 kilograms in 1 metric ton. Okay, so the kilograms go away, the pounds go away, the days go away, and you're left with metric tons per year. So again, here we would multiply all the numbers on the top, divide by all the numbers on the bottom. And you would get 2.32 times 10 to the 8th metric tons per year. Okay, so again, in these problems where we have lots of units, finding the simplest unit is a good way to find the place where you're going to start. Okay, once you have that established, the next thing would be to find out, that's obviously going to lead to the term that has that opposite, or putting that same term opposite, is where you're going to go. The only thing here that had people or persons in it is my top term. None of these other ones that had anything that would cancel out with how many people there are. Okay, and again, that kind of sets your, once you get 1 foot going, then it sets for the next foot to get going. Okay. All right, let's do just one more here. All right, this last one looks at the world record for adult running male for 1 mile is 3 minutes and 72 seconds, or 3.72 minutes. Okay, 3.72 minutes. And we want to calculate this rate in meters per second. Okay. So 1 mile for every 3.72 minutes. Sorry, go with a better color here. Trying to find something that is seeable. Okay, so we want to go from miles to meters. So in 1 mile, there is 1.609 kilometers. 1 kilometer is 1,000 meters. Okay, so by setting the units opposite one another, these ones divide themselves out. And then lastly, in 1 minute, there are 60 seconds. It doesn't matter which order you do these things in, okay, but what it leaves me with is meters per second. So if we multiply all the numbers on the top, divide by all the numbers on the bottom, we get 7.21 meters per second. Okay, so all of these are a little bit more difficult than what we looked at previously, but hopefully this gives you some idea where the challenge really comes in is when we're mixing in US units and our metric system units. So that's really where the challenge comes in some of these problems. Okay, all right, so that is it for this video, and we will check back later with some other practice problems, and we'll see if the next ones are just as hard.